We all know the sun is a powerful source of energy. Solar panels have become a symbol of clean, green electricity, especially in places where the power grid doesn't reach. But what if there's a different kind of energy, a more dependable, low-cost option, hiding in something we usually throw away? It might sound surprising, but in some rural parts of Africa, communities could one day trust bacteria more than they trust the sun to power their lives. That's not a joke. It's science, and it could change everything. Solar energy is clean, renewable, and available in many parts of Africa nearly every day. That makes it sound like the perfect solution, right? And in many ways, it is. But for people living in rural areas, the reality of solar power can be more complicated than it seems. First, solar systems aren't just panels. They require batteries, wiring, charge controllers, inverters, and sometimes even internet-based monitoring. These parts often need repairs or replacement, and when something goes wrong, it can be difficult to find a technician or afford the parts. In rural villages, people may have to travel long distances or wait weeks just to get help. Then there's the problem of storage. Solar panels only produce electricity during the day, and the sun isn't always strong, especially during rainy seasons or in dusty environments. Without reliable batteries, people are left without power at night when they need it most, for lighting, cooking, security, and charging phones. All of this means that even though sunlight is free and plentiful, the systems that turn it into electricity aren't always reliable in remote areas. That's why communities are beginning to explore other energy options that are more affordable, easier to maintain, and better suited to daily village life. A microbial fuel cell, or MFC, is a small energy system that turns waste, like food scraps, sewage, or animal droppings, into electricity using bacteria. These bacteria are natural microorganisms that already live in the environment and help break down organic matter. In a microbial fuel cell, the bacteria are placed in a container with the waste. As they feed on this material, they release electrons as part of their digestion process. These electrons are collected by electrodes and flow through wires, creating an electric current. It's like turning a compost pile into a battery. The idea may sound futuristic, but it's actually based on natural processes that happen every day in soil and water. Scientists have simply found a way to capture the energy that bacteria already produce as they go about their work. The result is a system that doesn't rely on sunshine, wind, or fuel, just waste and microbes. Because it uses simple resources that every community already has, the microbial fuel cell could be a powerful tool for places that don't have regular access to electricity. It's clean, quiet, and can even help manage local waste while producing energy. To understand how a microbial fuel cell works, imagine two small containers connected by wires. In one container, called the anode chamber, bacteria are placed in an oxygen-free environment along with organic waste like leftover food, dirty water, or manure. These bacteria feed on the waste and begin a natural chemical process. As they digest the waste, the bacteria release electrons and protons. The electrons flow into a nearby electrode and move through a wire, creating electricity. The protons move through a membrane into the second container, called the cathode chamber, where they combine with oxygen and the returning electrons to form clean water. This cycle repeats again and again as long as the bacteria have waste to feed on. What's special is that this entire process happens without any fuel, without fire, and without pollution. It's slow and steady, but reliable. The amount of electricity produced from one microbial fuel cell is small, but when you connect several together, they can power useful tools like LED lights, mobile phone chargers, and even small pumps or sensors. That's often all a household or community health center needs. In many rural African communities, energy isn't just about brightness, it's about dependability. If a light can't turn on when needed, if a phone can't charge before someone travels, or if a health clinic loses power at night, the impact is real. Solar power is wonderful, but it's technology-heavy. It relies on supply chains, regular maintenance, and imported parts. When those fail, people are left in the dark. But microbial fuel cells are different. They're low-tech, low-maintenance, and based on resources people already have. Every village has waste. Every household produces it. And bacteria? They are already in the environment, waiting to be put to work. This gives microbial fuel cells a special kind of value, energy independence. It means people can build and manage energy systems without outside help. And when something breaks, the solution is nearby, not far away. In communities where access to money, tools, or technicians is limited, that kind of self-reliance makes all the difference. People can trust something they understand, something they can fix, something they see working every day, no matter the weather. One of the most exciting parts of microbial fuel cells is how they put power, literally, in the hands of the people. MFCs don't need huge factories or international companies to run. They can be built with basic materials, clay pots, carbon rods, wires, and containers that can be sourced locally. With a bit of training, communities can build and maintain these systems themselves. Students in local schools can learn the science behind them. Farmers can turn animal waste into energy. Women can use kitchen scraps to generate light for evening activities. And health clinics can charge phones and run small equipment, even at night. This kind of local control brings more than just electricity. It builds knowledge. It builds confidence. And it creates new opportunities for innovation at the village level. What starts as a small energy source becomes a symbol of resilience and progress. At the moment, microbial fuel cells are still developing. They can't yet power a whole house or a television, but they can do a lot with a little. MFCs can keep a light on for hours. They can charge a mobile phone overnight. They can power sensors that monitor water quality, soil health, or crop conditions, important tools for farmers and schools. In some places, they're even used to support small irrigation systems or power low-energy fans. These may seem like small things, but in places without reliable electricity, they can make a big difference. A student can study after sunset. A health worker can call for help. A farmer can track when to water crops. These are real, daily benefits that improve lives. And as the technology improves, the power output of microbial fuel cells will grow too. The goal isn't to replace the grid overnight. The goal is to start where people are and grow from there.